All right. So 5.1, the antiderivative and indefinite integral. So here's a formal definition. So a function, capital F, is the antiderivative of lowercase f on an interval capital I when capital F prime of x is equal to lowercase of x, lower f. For all x. Okay. So that's formal definition. So here's theorem 5.1. If capital F is an antiderivative of lowercase f on I, then, so here we use capital G. G is an antiderivative of lowercase f on I. If and only if and only if G is of the form capital G of x equal to lowercase f of x plus c for all x. Where c is a constant. Okay, so in this case, G is called, or also called, the general solution. Okay. So in other words, the integral of f of x, lowercase f of x, dx is equal to capital F of x plus c. Lowercase f of x is called the integrand. dx is the variable of differentiation. Capital F of x is the antiderivative of f of x. So I'm trying to define everything for you, and then we can move on. And C is also called the constant of integration. So integration is the inverse of differentiation. So in other words, the opposite of the derivatives. So if we integrate a derivative, we will get the normal function back, but with a constant of integration. Okay. Also, if you were to take a derivative with respect to x of an integral that's integrating with respect to x, they will cancel, leaving you with just the function. Okay. Let me give you a bunch of basic rules, and then we'll start doing examples. Just a moment. All right, let me give you the basic rules. So number one, the integral of 0 is c, some constant. Number two, the integral of some constant k is equal to k times x plus c. Number three, if you integrate something that has a variable like k times f of x, you can pull out that k if k is a constant. Oops, forgot my dx over here. Okay, integral of f of x plus or minus g of x dx is equal to the integral of f of x plus or minus the integral of g of x. Oh man, forgot the dx again. Okay, this isn't just saying that you can separate and integrate separately. Number 5, if you have an integration of a power function, all you have to do is add 1 to the power and divide by that same number. But you always have to add your c. This is assuming that n is not equal to 1. Oh, I'm sorry, -1. Number 6, integral of cosine x dx is equal to sine plus c. Integral of sine will be negative cosine plus c. Integral of secant squared dx is equal to tangent plus c. Integral of secant x tangent x dx is equal to secant x plus c. Yeah, cosecant squared is equal to negative cotangent. Almost done. Integral of cosecant x cotangent x, yeah, that's right, is equal to negative cosecant x plus c. Integral e to the x dx is equal to e to the x plus c. Integral of some number to the x dx is equal to 1 over ln a times a to the x plus c. Okay. Let's do some examples and then we'll move on to 5.2.
Can you scroll up a little bit?
Yeah. Right there or more?
Yeah, that's good. That's good. Thank you.
In number 13, you have 1 over ln a.
Yeah, 1 over ln a times
Okay.
a to the x plus c. All right. Let's start some examples. Okay, first example. Find the general solutions of the following. Okay. So dy dx equal to 7x to the 3/4. Find the general solution. So all we have to do is integrate both sides. There's a couple ways to think about it. I like to just go straight to this rule here and just say, you know what, I'm going to integrate this guy with respect to dx. So the rule that we have one rule that says we can pull out the 7 and then deal with this. So add 1 and divide by that value. So that'll be 7 times x to the 3/4 plus 1. And then we need to divide by that same number. 3/4 plus 1. And once you've integrated, you have to put your c and no longer write the symbol. Okay. So these are all equal here. So that will be, so 3/4 plus 1, what's that going to be? That's 7/4, right?
It's 7/4.
Which will give us 4/7 times 7 times x to the 7/4, right? After we do our algebra. No big deal so far, or what are you guys doing? Still following me?
Okay,
I might need you to repeat it a little bit.
What's up?
I might need you to repeat it a little bit.
So 3/4 plus 1, you get this common denominator, right? That gets us 7/4. When you divide by a fraction, you gotta flip and multiply, right?
mhm.
So
Right.
then these will cancel, leaving me with the 4, and that's it.
Okay, good.
All right. So if you have a number in the outside when you start, you can always just pull it out and deal with it later. See how we didn't even mess with it at first?
Yes,
So you can do that with any constant. Okay. Let's say you have 4 times square root of x. All right, so I need to integrate 4 square root x dx, right? I can pull the 4 out. I'm gonna try to separate this. But now I have this root, so we have to change this into 4 integral of x to the 1/2 dx, right? Because that's the same as a square root, correct?
Yeah.
So now we use the same rule. So we get 4 x to the 1/2, and you add the 1, and then whatever you get up there, you got to do to the bottom plus 1. So that's the integration step. So once you've done that, we'll get to 4 x to the 3/2 at 1/2 plus 1 is 3/2 over 3/2. So do your fraction step, and that should be what? 8/3 x to the 3/2. So all we used was the power rule twice. Is this familiar from last, or I guess we took it, you did it in the spring, right? Most of you?
Yes.
Is coming back?
Yeah.
Yeah.
So it's the same exact thing we did, your final, your last chapter in the spring. Same thing. I'm just repeating myself. You guys cool on this page? Any questions?
Yeah. Can you hold on a little bit?
Yeah, no rush.
Okay.
Let me know.
Okay.
All right, let's do another one, but this time we'll have two pieces so you can see how we can use a sum and difference rule. So same question, just integrate this guy. So parentheses 3 cosine x minus 2 sine x dx. So we can separate the integral to 3 cosine x dx minus 2 sine x dx, right? That was one of the rules. You remember?
Sine x dx. Okay, sine x. That's it. Okay.
Okay, so we'll integrate them separately and just pull out the constants in the way. So we're going to have 3 cosine x dx minus 2 sine x dx. So what is the integral of cosine?
Cosine is sine x plus c.
Yeah, this will be simply 3 sine x plus c. But we'll put the c at the end because there's only going to be one c. Though you're right though. What's the integral of sine?
Minus cosine x plus, well, minus cosine. So
So it'll be negative cosine x. So we'll put the c over here. So the reason I do it this way is because technically you would have two different c's. No, you're not wrong. But you can rename this c to be, like, let's pretend we got c1 and c2, right?
Mhm.
I can let C equal to C1 plus C2. So you see how it doesn't matter. Because C is some number. So if I add two numbers that are some number, it's just some other number. Who cares? That's why I don't bother writing it until the end. But it's not incorrect. So negative times negative, right? There we go. One second. That makes sense. Is there any questions on this guy?
No,
Okay. So let's move on to 5.2. You guys cool on the basics of integration? That we went over the power rule, the sum and difference rule, the constant factor rule. So on 5.1, you have a bunch of different practice problems. After you go through, you should remember the basics, I hope. 5.2 is about summations. So let's go ahead and talk about summations. That's cool. Done with this page?
yes,
Yes, before we continue, I just have a quick question.
What's up?
Like let's say we get the antiderivative one and we still get like one of these basic rules of integration. Do we still keep going and simplifying until we can simplify no more? Or
Yeah, I
do we
mean, if
just do the
there's,
first one?
if you're wondering if there's, you're talking about stopping here?
Yeah, I'm talking about like let's say in a different example, like just random. You have one where you end up getting another basic rule of integration. Do you still keep doing more, or do you keep simplifying, or do you just stop after the first when you get the first integration?
But once the integration step is done, you might have to do some algebra, but nothing. You should simplify a little bit, yeah.
Okay. Got it.
Like if you stopped here, I mean, I wouldn't be too upset, but you might as well keep going. Like, or if there was a couple of algebra steps, I'd say just do it.
Okay.
Okay. So do you guys remember what the sigma notation meant?
I don't remember anything, so.
Okay. Let me go and talk about it again. I'll just read you the notebook over and over again. So the sum of n terms, A1, A2, A3, all the way till
Oh, yeah,
AN, right? That's the same as saying the sum, sigma, capital sigma, from I equal 1 until n of A sub I. So you start at the 1, and then you do plus the next one, which is 2, all the way until n, which is some number. Right?
yes,
So I is the index. So this is the index. 1 and n are the bounds right here. I want to draw an arrow up there, but anyway, let's do an example. That'll make more sense then. Find the sum. I equal 3 to 6. Of I guess we can use k. K over k plus 2. So I'm starting at 3 and going all the way till 6. So k equal to 3 would be 3 over 3 plus 2 plus the next term 4 over 4 plus 2 plus 5 over 5 plus 2 and then 6. Right? Oops, sorry. So then just add them up and you're going to get 3/5 plus 4, 6 plus 5, 7 plus 6, 8. Which is, let's skip the step here. I think I wrote it down earlier. 1147 over 420. All right, so all you got to do is start at the beginning till the end. Any questions on the notation?
What is that? A on top of the k plus 2? Right by up below the find the sum.
Oh, it's a K.
K.
It's supposed to be a K. Give me 1 second. Any questions on this, or is that okay so far?
Good, we're good.
Yeah, let me give you some formulas because you're gonna need them for the homework.
You screw it up? Yeah, your paper up.
Yeah, I don't know if it'll fit, but yeah, let's do a different page. Oh, so you need the top?
No. I said if you're gonna write, like screw it or down.
Oh, you're good, you said? Okay.
Yeah, I'm good.
Summation formulas. So number 1, if you're summing something all the way to n, so this will help you skip steps. Or if you have questions that are not finite, then you use this. So if you're summing something from 1 to n, some constant c, the answer will be Cn. C is a constant. Number 2, the sum from I equals 1 to n, if it's just an I by itself, that would be equal to n times n plus 1 over 2. So you just plug in whatever n's in there and you have the total sum. Skip steps. Number 3, if it's a square, I squared, that's going to be n times n plus 1 times 2n plus 2. I'm sorry, 2n plus 1 over 6. If it's a cube, then you'd have n squared times n plus 1 squared over 4. Okay. Let's try one. That'll look like your homework. Let's see here. Yeah, let's do this guy. This one's pretty cool. Evaluate the sum I equals 1 to n, I plus 1 over n squared. They wrote kind of small. Can you see that?
Yes.
So notice there's already an n in there. So you can pull this outside, but it doesn't have the same index. It's if it was an I, the i's have to stay. The n can come out. So you can just say, you know what, I'm gonna deal with this first. I plus 1. And then you can separate the summation. They have 2 separate summations. So I'm going to do the EI and the 1. Oops, I got to put the down 1 over n squared. Well, I can do it this way. So you can apply the formula to these two, right? What is number 1 going to be? What's the answer?
Number 1.
Look at number 1. Right, we said any constant would just be c
Yeah.
times that, n times that constant. We have a number 1. So the answer would be just n. Right? N times 1. No, the I we said is going to be this. N times n plus 1 over 2. So the answer will be
Oh, okay.
n times n plus 1 over 2 plus n. That makes sense? I'm just using formulas. That's all we're doing. So let's just do some algebra and we're done, right? I'll add these up. That'll be n n times n will be,
N square.
yeah, n times 1. If I want to add this over here, I need to multiply by 2, so that'll be 2n. over 2, which will be n squared plus 3n over 2n squared. But I guess I could factor one out, right? Either way, I skipped the algebra step at the end. Is that okay from here to here? So if the homework said that n was 10,000, right, you would just plug in 10,000 right here, right? You would get the sum. So instead of adding 1, 2, 3, 4, you can just use the formula and get the
Mhm.
total. So if they start telling you from I equals 1 to 20, and just do the formula and plug in 20. Right?
Would the answer be the same if the final is 3n over 2n, or that's not the same?
If you did one,
Is it the same answer? Instead of n plus 3, would be 3n over 2n. Is not the same?
well, I did I simplified this from here to here.
Yeah.
You want to see the step?
Yeah, please.
Yeah, let's show it. So we factor the n from the top. We end up with n plus 3. And then down there you have an extra n, right? So you cancel one of those.
Got it.
Okay. Let's do let me see, there's another, let me look at the homework real quick. Oh wait, let's find 2. There we go. Yeah, let me share the screen with you real quick. So you see how, so in this homework, I just want you to get an idea. The first one, you just plug in the number from 4 to 8, like we did the first example, right? You remember? Plug in a few, add them up. Over here, you could do the same, or you could use the formula and remember that n is equal to 5. So the answer would be equal to 5 times c, so 5c, using formula number 1. Over here, they want you to come up with the formula for the series. So how far does it go? It goes from 1, right? I is equal to 1, the index, and it ends at 12. So this would be from 1 to 12, right?
Mhm.
What is the pattern that you see? All the way down. For sure, there's a 6, right?
Yes.
And what else?
6.
6 plus n.
What is the 6 doing? Is it multiplying, right?
Yes.
Fine. Yes.
So it would just be 6i. So I would change all the way to 12, right?
Uh,
So see, that's all you need to do for 3 and 4. Just come up with a formula. Number 5, you can here you really should use the formula because it goes all the way to 17, right? So we should look at number 1 on your notes. We said summation formula. If it's some number C and it goes all the way to n, all you got to do is multiply C times the n. So my C is 7, my n is 17.
Mhm.
Multiply them together, and that's the answer using formula 1. Okay. This guy is formula 2. So you would plug in, you would look at number 2, see how it becomes n plus 1 over n times n plus 1 over 2.
Yes.
So you would plug in the 24 to all the n's and then multiply by 6, because that 6 is going to be out here, right? You see what I'm saying?
Mhm.
So that's all you do. You apply the formulas where you, whenever you see an I in there. This one's more like the one we did, or the last one we did, a little bit more complicated. So you would have to FOIL everything out, separate all the I's, and apply the formula to each one. But since it only goes to 5, you could get away with just plugging it in. But you should get into the habit of practicing, because the next one is exactly like the one we did, except I didn't plug in any numbers. Is there any questions on number 7 or number 8? Do you see what they're asking?
And then,
I see this is the same thing we just did, right?
mhm.
All right, I pulled out this I pulled this out for the front, and then I created one sum for this part and one sum for this part.
Mhm.
That's exactly what we did right here on example 3. It's just that at the end, they'd ask you an extra step. They say, you know what, plug in 10, plug in 100, whatever. That's pretty much it for the homework. Let's look at this. Let's do one of these real quick. I want to make sure you get an idea what's coming. So here's a limit that's attached to a sum. 1 second. Let's see here. Find the proof. The limit as n goes to infinity. Y equal 1 to n of 2 over n cubed times 2i minus 3 squared. So notice how we have a summation and the limit. There's a limit as n is approaching infinity, meaning I can't pull this out in front of the whole thing, but I could pull it out of the series. All right, so I could do this. Sorry, I lost my train of thought. I'll put the 2 over n cubed in front of the summation. And this I'm going to have to FOIL out, right? Need to distribute the 2 or expand it. So I'm going to get 4i squared minus 6i, oops, actually 12. So multiply this out, you'll get 4i squared minus 12i plus 9. It doesn't look very pretty, but let's go ahead and use the formula on each piece. Once we've done all that, we'll reintroduce this guy and then try to take the limit. Okay. Because we can do the limit until we get rid of those series, those sigma notations. Okay. So remember we said the I squared is equal to what on the formulas?
N times n plus 1 times 2n plus 1 over
6.
6.
So that 4 is whatever. Well, I guess I should show this step. So I'm going to separate the sigma on each one. Okay, so now let's start applying the formula to each piece. The constant is going to be pulled out, it doesn't matter, right? So we said that the I squared is going to become n times n plus 1 times 2n plus 1 over 6, right? So let's go ahead and start converting everything. This has to wait. So this becomes a 4 times n plus 1 times 2n plus 1
Square.
over 6, right?
You have a square, 2 plus 1.
No, I think it's just no squares.
No square.
The I squared turns into this.
Oh, okay.
Then this guy is going to be minus 12i, so that's going to be minus 12 times n times n plus 1 over 2 plus double check everything. Yeah. The last one will be just 9n, right?
Yeah, because it's the constant.
Mhm. You guys with me? Do you guys see how where all this came from?
Yes.
Okay, so at this point, we can start simplifying the top here. Let's see how it goes. So let's go ahead and multiply it out. So we get 4. I'm going to leave the 4 out here. So n times n plus 1, that'll be n squared plus n times 2n plus 1 minus is over 6. It's getting kind of messy, right? This will be 12n squared
12.
plus 12n over 2 plus 9. That minus will apply to everything, in here. Okay, almost there. So this will be 4 times n 2n cubed plus n squared plus 2n squared plus n. Right? Minus 12n squared plus 12n over 2 plus the 9. So now I have, it's pretty clear what I can do. Right, I can introduce the n cubed and take the limit and cancel out these two right away, right? Because these are, the n cubed will go to 0 faster, or go to infinity faster, so it'll zero out this guy and that guy. This has a cube, so it'll cancel each other out, leaving me with this constant and this constant. But let me show you. So I'm going to introduce this here. So I'm going to get 8 times 2n cubed plus n squared plus, I mean, I could combine these, but it's not going to matter, over 6n cubed minus 12n squared plus 12n over 2 plus 9. I forgot my n cubed and my n cubed. So now just take the limit. Do you see how when you take the limit, this will go to 0 and this will go to 0? Do you remember your K1? We said that if you have an infinite limit and the degree is bigger on the bottom, it will go to 0.
Mhm.
Because the fraction will be
Oh,
infinitely
okay.
small. So will this guy.
So if
So all we have to deal with is this. So we also said that if the degrees match, you take this number and that number. But I have an 8, so I have to take the 2 and the 8 together because I did not multiply it through. To make it more straightforward, I can pull the 8 in front so I don't confuse anybody. We'll deal with the 8 at the very end. So I'm going to keep the 2 and the 6. So the limit is equal to 2 over 6, which is, what, that reduces to what, a third?
A third, yes.
8/3. So we had to use the summation formulas, and then after that we had to use some limit ideas. So the last question or 2 questions are a little harder. That's why I want to do at least one of them with you guys, just in case you forgot the limits. Is there any steps anywhere here that doesn't make sense? Or if I lost you somewhere?
you can ask me rather where the 8 comes in the very front.
Oh, so the limits allow you to pull out constants. So I said, you know what, I don't want to leave it here because I'm taking the limit of everything.
Okay.
I don't want to,
Gotcha.
I mean, I can leave it, but it's easier to understand that.
Yeah, I know what you
Limit and then the 8 came along.
Yeah.
You see what I mean?
Yes.
I should have multiplied the 8 inside and then done the limit. But I just was tired of writing the same thing 5 times, you know. I figured this was a little better.
What is the final answer?
8/3.
So you only have to do on the last step where it says 2n q plus 2n square plus 2n square plus n. You just get the 2n square cube and 6n cube, right?
This part right here?
Yes.
Yeah, so when you take a limit and the degrees match, you just divide these two numbers.
Okay. And you discard the rest of the.
Yeah, the rest doesn't matter because they're not fast enough. When we talk about infinity, only these matter. Like for example, back in Cal 1, we had questions.
Oh
like,
yeah. When you have the thing that goes up faster than the other one, right?
yeah, it was like,
Okay. Yeah, I remember that.
remember?
Yeah. Yeah, I remember. Yeah. Okay. Mhm.
Yes, they brought back limits for one section, I guess.
Yes.
But it makes sense. I mean, there's a reason for it, but we're not going to get too in depth with the limits like we did last time. The last time we brought them in, we brought limits into the class in order to define the derivative. And then after we defined it, we used those shortcuts and the formulas instead of the long way. You remember that?
Yes.
So there's a long way to do integrals, but I'm not going to make you do that. But I just wanted you to at least experience how they use it. So
Yeah, well, thank you.
is they use these summations to find the area. So let me show you a picture here. So I'm gonna remove these from the homework. I think I already did actually. So the idea basically is that you have some curve. So instead of using the fundamental theorem of calculus, they have an infinite number of rectangles. And when you let the rectangles become infinite, that's when it becomes dx. The dx becomes infinitesimal, meaning the width is infinitely small, which means you get a perfect smooth curve. It's no longer little squares or rectangles. It fits perfectly because they're so infinitely thin. And that's where the theory comes from, and we're allowed to find area and integrals come into play. But we're not gonna go into this right now, so we're just gonna go to the fundamental theorem after 5.2. Make it easier.
Okay.
Okay. You guys have any questions on 5.2?
Mhm.
Let me check the schedule. Let's see where we're supposed to be at. Let's see. Yeah, I think we're good. So on Monday we will do we'll do 5.4 and then 5.5, which is the integration by substitution, and then the natural log integration. So I'm going to do 3 sections on Monday, and then Wednesday we'll just do like 1 section. Okay. And
Okay.
today we'll just stop here and not worry about it. So for now, what I want you to do is do the 5.1 and 5.2 homework and start the 5.4, and then we'll talk about it when I see you.
So we're not gonna do 5.3
No, 5.3.
or 5.3. Okay.
It shouldn't be there. If it is, let me know. I'll get rid of it.
Riemann Sims.
Yeah, that's
what?
the Riemann sums definite integral. That's the rectangle thing I'm talking about. We have to use.
Oh, okay.
Okay, another thing, I was trying to access the ebook.
Mhm.
And it didn't let me, like, we're not allowed or something. Access denied. I said, you know why?
Where did you try to access it from? From inside the homework or?
Canvas from I guess the homepage Canvas. There's
Try doing it this way. I don't know why that one doesn't work, but just go inside the homework and click ebook right here.
Oh, yeah, okay, yeah. I would do.
Just click here. This one should work for sure. I don't know why the other link doesn't work, but
Okay, yeah, good.
all right, guys. If you have no questions, call it a night, and we'll hit it hard on Monday.
Okay,
Yeah, my ebook, it says I have a 2-week trial. Like it's still not showing that I have like the whole ebook.
Let's see here. So
It's showing I did pay. Already applied, but
you needed to. Maybe I don't know if you missed something or not, but let's double check. Where the hell is it? Well, actually, this is Cal 2. So as soon as you click the homework, it should just send you right in. But you're saying that when you click 5.1 or 5.2, it tells you need to buy something, or what's going on?
basically, yeah. Can I share my screen?
Yeah, let me turn that on for you. Go for it.
All right, so if I click on one of these. What it's gonna take me to.
Are you using Chrome?
Yeah, I tried it on Edge, Microsoft Edge. It does the same thing.
Because I know people are having issues on Chrome for some reason.
Okay. Sorry, it's takes forever to load.
Yeah, like I think I'd recommend Firefox just because
Yeah.
they're not data hungry like Google is.
Yeah. Okay. Whatever loads. I don't know. I just pulled it up.
I don't see the ebook on my assignment on the actual Cengage assignment.
Really? Well, show me in a second. See what's going on.
yeah, me too. I don't see the book.
Okay.
I have to click on the actual assignment 5.1. And should I see it or? Yeah, no, I don't see it. Oh, yes, my ebooks. Hello.
Oh, you found it?
Yep, I found it.
Oh, okay, good.
Yeah, we have to click on the actual assignment like 5.1 and right on top on the tab, it says my ebooks. Yeah.
All right,
okay.
can you see my my screen now? Yeah. So
Yeah, I see.
it's
it.
showing
Oh, yes.
temporary access for this.
Strange.
This is my physics class. It's showing that one's purchased. Let's see.
Yeah, I shouldn't have.
You have to go into the assignment.
Yeah, and then it's showing I have like a
Click on my ebook.
2-week trial. Right here.
Yeah, the other, yeah. Over there, click on the book and the other one, not trial view in the book.
Right
Or
here.
over there, yeah, over there. Click it.
Moving slow tonight.
There we go. There we go.
Yeah, it comes up, but it's showing that I only have 12 days left.
Oh, really?
Yeah, that's what I'm trying to say. It's like asking for an access code or for a payment or something.
Yeah, either send me an email with your name and let's call it banner, and I'll send it to Cengage. And if you want it sooner, if you want to give them a call in the
Okay,
morning,
will
and
do.
if you
No
don't,
problem.
I can do it for you when as
Well,
soon
I
as
mean,
you get a
it's-
chance tomorrow.
I still have 12 days remaining, so it's not super urgent.
True. But yeah, just send me. Don't forget, and I have all your info because
Yep, we'll do.
we have it all in one place.
Oh, yeah. Sure.